Greetings to all. I, Anjali Chauhan, with my project partner Aditi Srivastav, is here to present our final year project entitled as Airline Price Prediction Using Machine Learning under the supervision of Mrs. Jaya Shukla. This is the vision and mission of our institute. Let's proceed towards the introduction part. Airline ticket prices can be vary dynamically and significantly for the same flight. These industries implement dynamic pricing for their tickets and base their pricing decisions on demand estimation model. The reason for such a complicated system is that each flight only has a set number of seats, so airlines have to regulate demands. In case where demand is expected to exceed capacity, the airlines may increase prices. This can be one of the reasons. There are several different factors on which price of the flight ticket depends. So, the objective of this project is to study how airline ticket prices changes over the time, extract the factors that influence these fluctuations, and describe how they are correlated. In pursuit of this goal, we present a review of customer side and airline side prediction models, also the dependency of the accuracy on the feature set used to represent airfare. We achieve our results by using machine learning. Now we will discuss what is machine learning. Machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. So, here we are using several machine learning algorithms to predict our airline prices. These are linear regression, support vector regression, random forest regression, k-neighbor regression, gradient boosting regression. The workflow of this project is: first, we will be using training data set as an input. Then in the next step, we will clean and prepare data according to the model requirement. All the unnecessary data like duplicates and null values are removed. In the next step, we will load the testing data set, which is similar to the training data set except the price column, because we have to predict the flight price with a test data set. In the next step, to develop the model for a flight price, many conventional machine learning algorithms are evaluated. They are as follows: linear regression, support vector regression, k-nearest neighbor, gradient boost regression, random forest regressor. And at last, we analyze the performance of a better and more tuned algorithm by comparing the output of the classifiers. The methodology is: firstly, we will import the dataset from the GitHub. Then we will split the data into train and test dataset. Then we will import the machine learning libraries using scikit-learn, in which we can implement our machine learning algorithms. And then we will run the Python code in the Jupyter notebook to predict our prices. Now for the feature selection, we focus on the features that mostly affect the price fluctuation, like airline, date of journey, source, destination, route, departure time, arrival time, duration, total stoppage, additional information about the flight, and price. Now we are taking training and test data on the basis of 11 features discussed in the previous slide. Here is the implementation and results. First, we are using Jupyter Notebook to read our train and test data. Then we will remove all the null values. Here are some graphs that are showing the categorical data visualization. These are some histograms to check data dispersion. Now, when we applied a linear regression algorithm to the data, this is what the price is predicted based on the values of mean and standard deviation. The first is linear regression with the standard deviation of 84.59. The second model is support vector regressor with the standard deviation of 94.73. Next, we have random forest regressor with the standard deviation of 80.15. Then there is k-neighbor regressor with the standard deviation of 107.80. And at last, gradient boosting regressor with the standard deviation of 62.75. On the basis of these values, I would like to conclude that there are two major algorithms from which we got the optimal standard deviation, that is random forest algorithm with the standard deviation of 80.15 and gradient boosting algorithm with the standard deviation of 62.75. Here are some details of research paper and publication. Research paper entitled as Airline Price Prediction Using Machine Learning has been reviewed and published in the International Journal of Research in Engineering, IT, Social Sciences. Here are some snapshots of the certificate of publication. Thank you.